completely. The stainless steel is a beautiful material in the sense it captures light in different ways at different times of the day.
The shimmering beauty of the Petronas Towers today can be attributed to the efforts of hundreds of metal workers who clad her armor of stainless steel. In order to match the 4-day per floor cycle of tower building, they had to devise a special process that involved prefabricating a unique wall panel system. The man behind the metalworks company responsible for knocking these wall panels into shape is Mr. Cha T. In just 2 years, Cha T and his team would have had to cut and assemble a total of 33,000 panels, installing 120 of them into the towers each day.
When we got the contract in 1993, we have a factory area about 75,000 square feet. This is our commitment to the client to expand our factory, to double it, so that we can cater all the manufacturing and assembling activities in one area.
It was the largest amount of stainless steel that Cha T ever had to work with. He quickly realized that to cut the panels accurately in the given amount of time, he would need reinforcements. This is the V-cut machine from Japan. A power cutter that combines the sharpness of a samurai sword with Japanese precision technology.
We need the V-cut machine to V-cut all the corner, all the bend corner, you know, so to give you a very sharp look.
The steel claddings may owe their clean curves to the latest in Japanese technology, but the idea behind them stems from a more artistic source. They are a result of architect Caesar Pelli's plan to reflect the changing light of the Malaysian tropical climate in the tower's design.
We wanted to capture some of the feeling of a tropical building, some of the sense of exuberance and the richer play of light and shadow, the kind of double light that you have in the rainforest.
Even though the steel cladding and tower construction are running smoothly, engineers still face the challenge of ensuring the building remains as straight as an arrow while going up. The alignment of the buildings is checked every day to ensure it doesn't sway from the direction of its upward climb. Everything seems to go smoothly, but as the towers reach the 40th floor, the engineers are struck with their worst nightmare. One of the towers is discovered to be leaning a few millimeters off tangent, and no one understands why this is happening. This is a major cause for concern.
Because to us, millimeters could translate, if you don't correct the millimeters, it could translate to centimeters and to meters. I was afraid. We have a tilting tower in KL. I was afraid of that.
With the leaning tower now looking like a potential disaster, all work on the building stops until a solution can be found. As general manager, P. Krishnasamy was in charge of monitoring progress reports from surveyors and engineers.
I think at that time, because we didn't understand it, I think it became a bit of a scare for a lot of people, because we'd never been there. We then went to people who had built it before, at Sears in Chicago, and they kind of picked it up very fast to tell us, this is what will happen and the reasons why that happened.
The solution the Malaysians discovered was to generate a stronger opposing lean to cancel out the current leaning problem.
During construction, we would overcorrect the building in the opposite direction. We will build it such that if it were to lean in one direction, when we overcorrect it, end of the day, it comes to the correct verticality.
Ironically, to fix a crooked skyscraper, engineers have to make the building equally crooked, but in the opposite direction.
Fortunately, the deviation was small, and the correction required was minimum.
Now that the tower's verticality is restored, engineers turn their attention to the next big challenge: hoisting a 325 metric ton sky bridge to the 42nd floor of the Petronas Towers. It's a bold plan, made bolder by the fact that it's never been attempted on skyscrapers of this height. Standing 170 meters above street level and spanning the Petronas Towers is the highest sky bridge in the world. Today, the sky bridge is the centerpiece of the national landmark and one of the main reasons why the Petronas Towers are unique.
The idea for the sky bridge started as an aesthetic, artistic intention with a symbolic meaning. Connecting them with a bridge made them more clearly into a portal to the infinite, a portal to the sky.
Besides serving a symbolic purpose, the sky bridge also has a functional role.
All right, ladies and gentlemen, you're given 10 minutes on the bridge.
It serves as a corridor connecting the two towers. To manage the flow of traffic, designers also made it a dual-level bridge. People can get from one building to the next at midway without having to travel down the length of the tallest towers in the world for the same purpose. Though the sky bridge brings with it form and functionality, incorporating it into the Petronas Towers did not come easy. Even at the design phase, the bridge proved to be a major challenge.
The sky bridge design went through a number of stages of redesign. It, I think, went through 5 different stages of design. At the launch of the project, the sky bridge had a little bit of a spider web kind of a feel to it.
The original design had a series of steel wires locking the bridge to the towers. This was based on the theory that they helped to create stability. But when structural engineers studied the design more closely, they discovered the theory was flawed.
We were faced with a problem here on a technical point of view, the movement. We know it is a fact that both towers could move differently. Now, when both towers move apart, we know that if we fix the bridge to the towers, there will be tearing forces.
The original web-like design of the sky bridge had to be discarded. Designers and engineers then looked into other potential replacements before settling on a new plan. The solution was to float the bridge. It involved building an inverted V-shaped arch that supports the bridge in the center. 2 end bearings accommodate any movements caused by the natural tendency of the towers to sway.
In fact, the design is that at the center of this point, at each of these bearings, the bridge is allowed to move 3/4 of a meter in either direction of the center. That is what I meant by floating. It is not fixed.
With the new design approved, engineers had Korean steel experts, Samsung Heavy Industries, prefabricate the sky bridge and ship it over to Malaysia.
It was important to make sure that every single element of the sky bridge had to be perfect.
A convoy of large trailer trucks transport over 400 bridge parts through Kuala Lumpur. But this is nothing when compared to the bigger challenge that awaits them on site. Raising the main parts of the sky bridge to more than 100 meters above ground and then assembling them in mid-air.
Since it's going to be constructed in the mid-air, we can't afford to make any mistakes. If you have any slight mistakes, you can't do anything with it, you know. So you have to make sure that it's right the first time.
On arrival, the bridge parts, weighing in at more than 400 tons, are carefully removed from the trucks. The skybridge is reassembled into 5 sections, comprising the 2 40-meter-long legs, the 2 ends of the bridge, and its midsection. In no time, the lifting operation commences. The process begins with the lifting of the bridge's legs that each weigh 60 tons. Powerful hydraulic jacks help to ease a complex and dangerous operation. Each leg is slowly maneuvered into a vertical position over their permanent bearings at level 29 and secured. With this part of the process completed, lifting crews turn their attention to the bigger challenge of the operation: lifting the 325-ton bridge midsection. This will not be an easy climb. The lifting operation begins. The midsection makes the ascent slowly at 12 meters an hour. Engineers carefully observe each second of the process. In an operation that will take more than 30 hours to execute, anything can happen. Sure enough, it does. A tropical storm suddenly erupts over Kuala Lumpur. But there was no way the engineers could stop the bridge midway through its ascent. So the lifting continues. As the lifting draws closer to the end, everyone thinks they got the better of Mother Nature. Until the lifting mechanism of the bridge section stops without warning.
What happened was the computers that was used to lift up the skybridge got struck by lightning, and the whole process actually stops. And they had to actually repair it almost overnight. We can't leave the midsection dangling there, not knowing what's going to happen next. So I think everybody was actually praying. That was the sleepless nights. I used to sleep most of the time, but that was one time that I didn't sleep at night.
To everyone's relief, the problem is quickly resolved, and the bridge continues its ascent to reach its intended height. After almost 3 days of painstaking lifting work, the bridge finally gets bolted into place, with its legs resting firmly on both towers. The goal of building the highest sky bridge in the world has finally been realized. With the sky bridge now in place, engineers turn their attention to another defining feature of the towers: the pinnacles. It's hard to believe that these elegant structures, so comfortably perched on the top of the tallest twin towers in the world, were never in the original plan of the buildings.
In the original submission by Pelly, the roof or the top of the building was a flat roof. So it seemed abrupt. To the owners, it seemed an abrupt ending, or rather an abrupt crown to the building. Seems incomplete. So Mr. Pelly was asked to come back with several options.
It was a very difficult element to design. We had more alternatives for the pinnacles than for any other element of the tower. It was just how to capture the right quality, the right flavor for the pinnacles.
The design solution came, once again, from the earlier connection Pelly made with Islamic art and culture to create the look of the Petronas Towers. This time, he looked closely at the curved beauty of the domes on mosques all over the city and decided to adapt their design for the tower's pinnacles.
It's a very subtle intellectual relationship, but somehow it is felt, and people feel it, connect with it, and can sense that this is a form that connects with their culture, connects with Islam, connects with Malaysia.
Convinced by the reasoning behind this design, Pelly pitched the idea to the building's owners. Everyone is sold on the idea, but it was more than just the unique design that appealed to them.
With the pinnacle, it essentially pushed this building to become the tallest building then. It would have gone up 452 meters, making it slightly taller than then tallest building in the world, which was Sears Tower. So, it's almost by accident, but it was created because of a need statement, which said that there was something incomplete in the design.
Without the pinnacles, the Petronas Towers would rise to 379 meters. Adding the pinnacles meant an additional 73 meters in height. It's like adding another 20 stories to the towers. After Pelly's design was approved, the prefabricated parts of the pinnacles arrived from Japan. Each 176-ton pinnacle is split into different segments and transported carefully to the building site. Erecting the steel mast of the pinnacle was a masterstroke during an installation that took 3 full days. Engineers lifted the parts to the 83rd floor and with the help of a hydrojacking system, raised each segment of the mast bit by bit through an opening in the roof.
We did it like a Lego set, you put the pinnacle there and then the next bit and the next bit and the next bit, and then we hydraulically jacked it up. I mean, that was my favorite part, of getting it to that and becoming the tallest. And we did that about 3 a.m. in the morning.
Though the method of constructing the pinnacles was hidden from view, the results can now be seen in their full glory for miles around. For designer Cesar Pelli, raising the pinnacles represented not just the inventiveness of engineering, but is also symbolic of the aspiration of mankind.
They carry your eye to the top, and it allows you for your eye to continue to the sky, to heaven.
It took more than 8 years of planning and construction, but today, the Petronas Towers are one of the most sought-after international business addresses in the world. They have become the national icon of Malaysia and have established a true sense of a city centre for Kuala Lumpur that did not previously exist. But this national icon is far from an idle monument. As the thriving hub of the city centre, the Petronas Towers have over 10,000 occupants from all over the world, demanding the highest standards of safety and comfort. From day one, Abdul Hadi has been the man overseeing the building operations of the towers.
The biggest challenge here is the safety of our 10,000 people within this building. It's any new buildings with the new equipment, new installation, you don't know exactly how the system is going to behave. You have to run it to make sure that they work as per design.
To keep the towers operating at the highest international standards, the combined efforts of humans and machines are needed to make it run like clockwork. And doing this properly requires working round the clock. Even though the exterior cleaning operations run every day, it still takes the team almost 6 months just to complete one cleaning cycle. But it takes less than 60 seconds in the tower's unique high-speed lifts to get people safely up and down over 80 stories. It's a one-of-a-kind double-decker lift system that requires the biggest lift machine rooms in the world. But to truly be an icon, sometimes feats of engineering are not enough. If the super lifts are its heartbeat, than the 2,600 square meter, 850-seat concert hall represents the soul of the building.
My favorite part of this building is the concert hall. Why? To have a concert hall in an office building created immediately a recognition of the human needs.
The developers recognized the need for life around the towers early on. Finishing touches, like a 40-acre public park, would forever ensure the tower's special place in the city.
The building in itself is special, but the additions, which were not tangibly really part of the towers, but created the space, I think made it extra special.
What the Petronas Towers have done is they have brought the sense of symbolism, the sense of romance that a skyscraper can have. I think they have become classic skyscrapers in a par with the Chrysler Building or the Empire State Building. And as such, they have captured the imagination of people all over the world.